Hi students, problem number 18. A train in Mumbai, due to a defective engine, goes at 5/8 of its usual speed. It is going slowly by 5/8 of its usual speed and arrives some other railway station at 6:49 p.m. instead of 5:55 p.m. So the usual reaching time is 5:55, but due to its slowness, it is arriving at 6:49 p.m. So it is late by some time. At what time did it start usually? So we have to find out at what time the train will usually start if its speed is usual. So for that, first of all, we will find out the difference in time between 6:49 and 5:55. So 6:49 p.m. can also be written like 5. This 1 hour can be shifted here on the right side on minutes. So this will be 60 plus 49 minutes. Okay, 60 plus 49 minutes. So this is also equal to 5 hours and 109 minutes. 109 minutes. Okay. So 6 hours 49 minutes also can be written as 5 hours 109 minutes. So what is the usual time? It reaches as 5:55. So minus of 5 hour 55 minutes. So this difference is equal to 109 minus 5 is 54 minutes. And this is 5 minus 5 is 0. Stop. So the difference in time now is only in minutes. So 109 minus 55 is equal to what? 54 minutes. So the new time will be equal to the initial time plus 54 minutes. So this also can be written as t plus 54 by 60 hour. So 54 minute also can be converted into hour as 54 by 60. So new timing, and let the usual speed, I will take the usual speed is equal to x, and the new speed must be equal to 5/8 of x. So due to the defective engine, it goes at what? 5/8 of its original speed. So the original speed or the usual speed is taken as x km/h. So the new speed is taken as 5/8 x. And the original time, if you take as t, means then the new time is t plus 54 by 60 hours. So now I will write two equations. The first equation is t, the distance traveled divided by speed. So let the distance traveled be equal to d divided by the speed is equal to x. So this implies d is equal to x into t. So this is our first equation. When the train is traveling at the usual speed x, what is the distance traveled is equal to the product of the usual speed x into the usual time t. Okay. Similarly, I take the new speed. So for the new speed, this distance, the same distance only is traveled, but the speed is 5/8. So 5/8 times x. This is the new speed, and the new time taken is what? t plus 54 by 60. Okay. So same distance only is being traveled by both. Okay, both the situations, because from Mumbai to the reaching station the distance will be the same whether you go slower or faster. So that is the clue here. So this d is equal to xt, and d is also equal to 5/8 of x into t plus 54 by 60. So this is now equal to 5x divided by 8 into t plus This is 9 into 6. 9 6 are, this is 10 6 are. So this is 9 by 10. So this is equal to 9 by 10. So now D is equal to 5x by 8 multiplied by t. So this is 5 by 8x into t plus 5 into 9 is 45 divided by 8 into and one more x term is there, x. 8 into 10 is 80. Okay. So now this distance d minus of 5 by 8 minus of 5 by 8 into xt is equal to 45x by 80. So this is divisible by 5. 9 5s are. This is 16 5s are. So this is equal to 9x by 16. So this is one of the steps, that's all. So 5 by 8 into x into t is there. Instead of x into t, what can be substituted? It is d, is it not? So I can write 5 by 8 into d. Therefore, I can also write d minus 5 by 8. So 5 by 8 into d, this is equal to right hand side is 9x by 16. So this is 9x divided by 16. So d minus 5 by 8, I will take the LCM. So that this is 8d minus 5d divided by 8. This is equal to 9x by 16. So 3d divided by 8 is equal to 9x by 16. So I can cut 8 into 2. 8 2s are 16 and this 3 into 3 is 19. So this implies what is it? D is equal to 3 by 2x. So D is equal to 3 by 2 into x. Distance by speed. Therefore, distance divided by speed is equal to time, that is equal to 3 by 2 hour. This is equal to 1 hour 30 minutes. So this is the actual time taken to travel a distance d. So from Mumbai to the reaching station, how much time the train has taken? A time equal to 1 hour and 30 minutes. If this 1 hour 30 minutes is subtracted from the arriving time, this is the regular time taken, is it not? If you this is the regular time, I mean the duration of time for the running of the train. So this is the usual reaching time, 5:55. If this 1 hour 30 minutes is subtracted from 5:55, means the starting time, regular starting time can be calculated. Therefore, the regular or usual starting time, the usual starting time is 5 hour 55 minutes minus 1 hour 30 minutes. 1 hour 30 minutes. So this will be equal to 55 minus 30 is 25. So 5 minus 1 is 4. So this is 4:25 p.m. So this is the usual starting time. And 1.5 hours if the train will regularly travel with its original speed x, means it will reach the station at what? 5:55 p.m. So what is the answer here? 4:25 p.m. is the starting time. So what time did it start? Usually is 4:25 p.m. Therefore, which is the correct option? B. Therefore, option B is the correct answer. So this type of problem and all will take much time. Understanding itself will take much time. So this type of problems, still many are available in the competitive textbook series. You will have to practice well. I hope you must have understood this well. Fine.